Hello class, let's build a circuit to study Kirchoff's voltage law. Let's add the DC voltage source first. Next, let's add 3 resistors in series. Now let's connect our components. We'll change the values of each component next. Let's not forget to add our ground. There are 2 ways to measure the voltages and current in a circuit. We can use the multimeters or the measurement probes. We'll explore using the multimeters first. Let's add a multimeter to measure the current. In order to do so, we have to break the circuit first in order to add it to the circuit. Now let's connect it to the voltage source and R1. Double-click on the multimeter and change the measurement to A for current. We'll place the measurement display over here. Grab another multimeter. This one will be used to measure the voltage across R1. We'll repeat the same process for R2 and R3. Next, double-click on each multimeter to open the measurement displays. Now we are ready to simulate our circuit. As seen in the displays, the current equals about 1.5 milliamps, VR1 equals 7.5 volts, VR2 equals 1.5 volts, and VR3 equals 3 volts. We'll rebuild the circuit, remove the multimeters so we can use the measurement probes this time. Click on the measurement probe towards the bottom of the measurement toolbar on the right. We'll add the first probe here. Double-click on the probe so we can change some of its properties. We'll call this probe VR1 since it'll be measuring the voltage across R1. We only need the voltage displayed with this probe, so we'll turn the rest of the other readings off. Let's copy this probe and paste one for R2 and R3. Pay close attention to the placement of the probes. Now just some minor adjustments to make our circuit easier to analyze. The last probe we'll add will be used to measure the current. We'll place it here, although we could have put it anywhere in the circuit since all the elements are in series. Double-click on the probe to change some of its properties and displays. By design, the reference point of a voltage probe is ground, meaning that wherever you place the probe it will measure the voltage from that point to ground. However, you can change the reference point to measure the voltage across the resistors. In order to do so, you have to have another probe to reference. We already have VR2 and VR3, so we'll use these as our reference. DR3 doesn't need a reference probe since R3 is already connected to ground. Like stated before, voltage probes are designed to have the ground as the reference point. Now we can simulate our circuit. As seen, we get the same results as using the multimeter. Let's use this circuit to study Kirchoff's voltage law. Kirchoff's voltage law states that the algebraic sum of the potential differences in any loop must be equal to zero. In other words, if you travel around any loop in a circuit, the voltages across the elements add up to zero. To begin, let's make the general assumption that current is flowing from positive to negative. Therefore, for this circuit, the current will be flowing clockwise around the circuit. Now let's add the polarities of each element. For the voltage source, the short line of the voltage source symbol is always negative, and the long line is always positive. Now, take a look at the polarities of the resistors. Since we are expecting the voltage drop, or in other words, the voltage to be reduced across each resistor, and we made the assumption that current flows from negative to positive, this is the reason why you see the positive sign first for each resistor. Starting at the ground and going clockwise around the circuit, let's add the voltages. Remember, we made the assumption that current flows negative to positive, which means that when the current enters the negative terminal first of a component we add the voltage, and when it enters the positive terminal first we subtract the voltage. By doing this, you can see that the sum of the voltages around a closed loop equals zero. Like said before, Kirchoff's voltage law can be performed around any closed loop as long as you apply the correct polarities for each component. Let's consider the outer loop of this circuit. Let's add back the polarities of each component. Again, if we start at ground and go around the outer loop of the circuit, the sum of the voltages equals zero. Let's explore the lower loop. Kirchoff's voltage law still holds true. If we start at ground and add the voltages in the lower loop, the sum still equals zero. That concludes this video. If you like what you see, and learned something, please like this video and subscribe to the channel. Comment below any questions you may have or suggestions for other videos. Thank you.